electromagnetic interference from a furnace's electric motor, fan, or electronic components can cause radio frequency interference and harmonics, particularly when the electrical system has poor grounding, allowing stray currents to travel through ductwork or other conductive materials. Addressing these issues involves several steps. Firstly, bonding the ductwork to the electrical panel can help reduce electromagnetic interference and radio frequency interference. This is achieved by providing a low resistance path for stray electrical currents to flow back to the panel's grounding system. Use a suitable bonding conductor, typically copper, of an appropriate gauge determined by the size of the service conductors as specified in the National Electrical Code Table 250.102 cone. Securely attach the bonding conductor to the ductwork using approved clamps or connectors, ensuring good metal-to-metal contact. Connect the other end of the bonding conductor to the grounding bus bar in the electrical panel. Secondly, ensure that the house is properly grounded. Check the main electrical panel for a grounding electrode system, which is usually a copper rod driven into the ground, or a connection to a metallic water pipe. Test the grounding resistance to ensure it is within acceptable limits, typically less than 25 ohms. Use a ground resistance tester, following the manufacturer's instructions. If the resistance is higher than 25 ohms, additional grounding electrodes may be required. Refer to the National Electrical Code Article 250 for grounding requirements and methods. Thirdly, if the existing breakers are push-button type, it may indicate that the panel is old and may not have adequate grounding and surge protection. Upgrading the panel with newer breakers and surge protection devices could help mitigate electrical interference. When upgrading the panel, select a panel with sufficient capacity to handle the existing and future electrical loads. Ensure that the new panel meets current safety standards and is properly grounded according to the National Electrical Code. Install surge protection devices at the panel to protect against voltage spikes and transients. Fourthly, consider installing shielded cables for the affected radio and television equipment to reduce electromagnetic interference. Shielded cables have a conductive layer that helps to block electromagnetic radiation from entering or exiting the cable. Use filters or surge protectors specifically designed for radio frequency interference and electromagnetic interference suppression. These filters and surge protectors are designed to block unwanted frequencies and voltages, preventing them from interfering with electronic equipment. Install these devices at the power input of the affected equipment to provide maximum protection. Fifthly, have a qualified heating, ventilation, and air conditioning technician inspect the furnace to ensure that it is properly installed and operating. Faulty or noisy components may contribute to electrical interference. The heating, ventilation, and air conditioning technician should check the furnace's wiring, motor, and other components for any signs of damage or wear. They should also ensure that the furnace is properly grounded and that all connections are tight and secure. Additionally, keep the radio and television equipment as far away from the furnace as possible. Distance can help to reduce the amount of electromagnetic interference that reaches the equipment. Use a surge protector for the furnace to protect it from voltage spikes and reduce harmonics. A surge protector can help to prevent damage to the furnace's electronic components and reduce the amount of electrical noise that it generates. Consider using a line conditioner to filter out electrical noise from the power supply. A line conditioner can help to provide a clean and stable power supply to the furnace and other electronic equipment. If all else fails, contact a qualified electrician to investigate the issue further and recommend appropriate solutions. The electrician can perform a thorough inspection of the electrical system and identify any potential sources of interference. They can also recommend and install additional shielding, filtering, or grounding measures as needed. When bonding the ductwork, use a copper conductor size according to the National Electrical Code Table 250.102 cone based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge copper, the bonding conductor should be at least 8 American wire gauge copper. Securely attach the bonding conductor to the ductwork using listed clamps or connectors, ensuring that the connection is mechanically sound and provides good electrical contact. Clean the surface of the ductwork where the clamp will be attached to remove any paint or corrosion. Connect the other end of the bonding conductor to the grounding bus bar in the electrical panel, ensuring a tight and secure connection. When checking the grounding resistance, use a ground resistance tester that is designed for this purpose. Follow the manufacturer's instructions for performing the test. Typically, this involves driving 2 ground stakes into the earth at a distance from the grounding electrode under test. Connect the tester to the grounding electrode and the ground stakes and then perform the test. The tester will display the grounding resistance in ohms. The grounding resistance should be less than 25 ohms as per the National Electrical Code section 250.53 ATWO. If the grounding resistance is higher than 25 ohms, install additional grounding electrodes to improve the grounding system. These electrodes should be spaced at least 6 feet apart and connected together with a bonding jumper. When upgrading the electrical panel, select a panel that is rated for the appropriate voltage and amperage for the electrical service. For example, if the service is 200 amps at 240 volts, select a panel that is rated for at least 200 amps at 240 volts. Ensure that the panel has sufficient spaces for all of the required circuit breakers, plus some spare spaces for future expansion. Install surge protection devices at the main electrical panel to protect the entire electrical system from voltage spikes and transients. These surge protection devices should be listed to Underwriters Laboratories 1449 and have a surge current rating that is appropriate for the electrical service. When installing shielded cables, ensure that the shield is properly grounded. Connect the shield to the grounding system at one end of the cable, typically at the equipment enclosure. This will help to prevent electromagnetic interference from entering or exiting the cable. Use filters and surge protectors that are specifically designed for radio frequency interference and electromagnetic interference suppression. These devices typically use inductors and capacitors to block unwanted frequencies and voltages. They should be installed at the power input of the affected equipment to provide maximum protection. When having the furnace inspected, ensure that the heating, ventilation, and air conditioning technician is qualified and experienced. They should check the furnace's wiring, motor, and other components for any signs of damage or wear. They should also ensure that the furnace is properly grounded and that all connections are tight and secure. The technician should also check the furnace's blow motor for any signs of excessive noise or vibration, which could indicate a problem with the motor. Additionally, ensure that the furnace is properly maintained, including regular cleaning and filter replacement. This will help to prevent dust and debris from building up, which can contribute to electrical interference. Remember to consult the National Electrical Code for specific requirements and guidelines related to electrical grounding, bonding, and wiring. Article 250 covers grounding and bonding, Article 300 covers wiring methods, and Article 400 covers flexible cords and cables. Always follow safe electrical practices and wear appropriate personal protective equipment when working with electrical systems. This includes safety glasses, rubber gloves, and insulated tools. If you are not comfortable working with electrical systems, contact a qualified electrician to perform the work. In summary, addressing electrical interference from a furnace requires a systematic approach that includes bonding the ductwork, verifying proper grounding, upgrading the electrical panel if necessary, using shielded cables and filters, and inspecting the furnace. By following these steps, it is possible to reduce or eliminate the electrical interference and improve the performance of radio and television equipment. Remember to always consult with qualified professionals and follow all applicable codes and regulations. Specifically concerning bonding, if metallic ductwork is present, it's crucial to bond it to the electrical grounding system to minimize potential differences and reduce stray currents that can induce interference. The National Electrical Code, in section 250.104b, addresses bonding of metal piping systems and exposed structural metal. While it doesn't explicitly mention ductwork, the principle applies similarly, as ductwork can become energized or carry stray currents. The bonding conductor should be sized according to Table 250.102 cone in the National Electrical Code, which depends on the size of the service conductors. For instance, if the service conductors are 2/0 American wire gauge copper, the bonding conductor should be at least 8 American wire gauge copper. Attach the bonding conductor to the ductwork using listed clamps or connectors suitable for bonding and grounding. Ensure the connection is mechanically secure and provides good electrical contact. Clean the surface of the ductwork to remove any paint or corrosion before attaching the clamp. Connect the other end of the bonding conductor to the grounding electrode conductor, the grounded conductor, or the equipment grounding bus in the electrical panel. This ensures a low impedance path for fault currents to return to the source. Improper grounding can exacerbate electrical noise issues. The grounding electrode system should consist of a ground rod, ground plate, or connection to a metallic water pipe, as specified in the National Electrical Code Section 250.52. The grounding electrode conductor connects the grounding electrode to the equipment grounding bus in the electrical panel. Verify the integrity of the grounding electrode conductor and ensure it is properly sized and connected. Test the grounding resistance using a ground resistance tester to ensure it is within acceptable limits. The National Electrical Code Section 250.53 ATWO requires a grounding resistance of 25 ohms or less. If the resistance exceeds this value, supplemental grounding electrodes may be necessary. The electrical panel upgrade is another crucial step, especially in older homes with outdated electrical systems. Push-button breakers are an indication of an aging panel that may lack adequate grounding and overcurrent protection. Replace the old panel with a new one that meets current safety standards and has sufficient capacity for the home's electrical loads. Install arc fault circuit interrupters and ground fault circuit interrupters to provide enhanced protection against electrical fires and shocks. Ensure that the new panel is properly grounded and bonded according to the National Electrical Code requirements. Surge protection devices can help to protect sensitive electronic equipment from voltage spikes and transients. Install a surge protective device at the main electrical panel to protect the entire electrical system. Use additional surge protectors at individual outlets where sensitive electronic equipment is connected. These surge protectors should be underwritten as laboratories listed and have a clamping voltage that is appropriate for the equipment being protected. Shielding and filtering are effective techniques for reducing electromagnetic interference and radio frequency interference. Use shielded cables for connecting radio and television equipment to minimize electromagnetic radiation. Install ferrite chokes on power cords and signal cables to filter out high-frequency noise. Use line filters or power conditioners to clean up the incoming power supply and reduce electrical noise. A thorough furnace inspection by a qualified heating, ventilation, and air conditioning technician can identify potential sources of electrical interference. The technician should check the furnace's wiring, motor, and other components for any signs of damage or wear. They should also ensure that the furnace is properly grounded and that all connections are tight and secure. Pay attention to the physical placement of equipment. Keep radio and television equipment as far away from the furnace as possible. This can help to reduce the amount of electromagnetic interference that reaches the equipment. In some cases, simply moving the equipment to a different location can significantly reduce the interference. Consider using a dedicated circuit for the furnace to isolate it from other electrical loads. This can help to prevent electrical noise from the furnace from affecting other equipment in the same circuit. If the problem persists, contact a qualified electrician to perform a comprehensive electrical system inspection. The electrician can use specialized equipment to identify and diagnose the source of the interference. They can also recommend and implement appropriate solutions to mitigate the problem. Remember that electrical work can be dangerous. Always follow safe electrical practices and wear appropriate personal protective equipment. If you are not comfortable working with electrical systems, contact a qualified electrician to perform the work. When dealing with electrical interference issues, it is important to take a systematic approach and consider all possible causes. By following the steps outlined above, you can effectively troubleshoot and resolve the problem. The solutions discussed previously regarding the furnace interference causing noise in radios and television sets highlights the importance of grounding and bonding. Let's delve deeper into these concepts and how they relate to electrical safety and electromagnetic compatibility. Grounding refers to connecting the electrical system to the earth, providing a low impedance path for fault currents to flow back to the source. This helps to quickly trip circuit breakers or fuses in the event of a ground fault, preventing electrical shock hazards and minimizing damage to equipment. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding involves connecting all non-current carrying metal parts of electrical equipment such as enclosures, conduits, and motor frames to the grounding system. This ensures that these metal parts remain at or near ground potential, preventing them from becoming energized in the event of a fault. System grounding involves grounding one of the current carrying conductors of the electrical system, typically the neutral conductor. This provides a stable reference point for the voltage and helps to limit voltage surges and transients. Bonding refers to connecting together all metal parts of the electrical system that are not intended to carry current. This includes metal conduits, metal enclosures, metal water pipes, and metal ductwork. Bonding creates a low impedance path for fault currents, ensuring that all metal parts are at the same potential. This helps to prevent electrical shock hazards and minimizes the risk of fire. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding. It specifies the types of grounding electrodes that are permitted, the size of the grounding and bonding conductors, and the methods for connecting the grounding and bonding conductors to the electrical system. Proper grounding and bonding are essential for electrical safety and electromagnetic compatibility. They help to prevent electrical shock hazards, minimize the risk of fire, and reduce electrical noise and interference. When troubleshooting electrical interference issues, it is important to carefully inspect the grounding and bonding system to ensure that it is properly installed and maintained. Look for loose connections, corroded conductors, and improper grounding methods. Correct any deficiencies that are found and retest the system to ensure that it is functioning properly. In addition to grounding and bonding, there are other measures that can be taken to reduce electrical noise and interference. Shielded cables can be used to block electromagnetic radiation from entering or exiting the cable. Filters and surge protectors can be used to block unwanted frequencies and voltages. Line conditioners can be used to clean up the incoming power supply and reduce electrical noise. By taking these measures, it is possible to create a cleaner and more reliable electrical environment.